Let's transform skeletal formulas into condensed formulas. In the first example, we have a cyclic compound where the ring consists of 6 carbon atoms. Let's write those carbons down. Next, we mark the substituents. In this case, we have 3 identical substituents made of 1 carbon atom each. The final step is to add hydrogen atoms to each carbon so that every carbon has 4 bonds. This is the most important rule in organic chemistry. In the next example, the compound has the longest chain of 4 carbon atoms. 2 of these carbons are connected by a double bond. Also, there are chlorine substituents on one of the carbon involved in the double bond. To finish up the formula, we add hydrogens. The first carbon has only 1 bond, so we add 3 hydrogens. The second has 2 bonds, so it gets 2 hydrogens. The third carbon already has 4 bonds, so no hydrogens are needed. And the last carbon has 2 bonds, so we add 2 hydrogens. The third compound doesn't have any substituents, but we can see a triple bond in the structure. When a compound has a triple bond, it's easy to miss carbon atoms. In this case, there are 7 carbon atoms. Let's mark them for clarity. Now, let's write the condensed formula. 7 carbons are connected via carbon-carbon bonds, and the third and the fourth carbon we place a triple bond. As always, the last step is to add hydrogen atoms, so that each carbon has 4 bonds. Now, let's look at the 3 new structures. In the first one, the longest chain is 6 carbon atoms long. On the last carbon, we see a carbon-oxygen double bond and a carbon-OH bond. Additionally, there are 2 one-carbon substituents on the same carbon, and 1 substituent made from 2 carbon atoms. Finally, we add hydrogens to complete the condensed formula. Next, we have another 6-carbon ring structure. However, this time, the ring has 3 double bonds. Let's mark them in blue. There is also an H2 group and 2 carbon substituents present. Let's include them in the condensed formula. To finish the structure, we add hydrogen atoms. In the next compound, the longest chain is 5 carbon atoms. Let's represent them as carbon-carbon bonds. On the first carbon, there is a double bond with an oxygen atom. We have 3 carbon substituents on the second, third, and fourth carbons. Lastly, we add hydrogens to complete the structure. In the final example, the longest chain contains 6 carbon atoms, with double bonds at the first and last positions. We also see a chlorine substituent, a 2-carbon substituent, another carbon substituent, and 2 bromine atoms. As always, we finish the condensed formula by adding hydrogens, so that each carbon has 4 bonds.